All right, good morning everyone. Welcome to Jack on the Gal, the Galar room, and I'm very pleased this morning to welcome Erin Zimmer, who's going to come and talk to us about refactoring components, and already I love the talk with the refactor tractor. Erin is a Google developer expert with over 15 years experience in a variety of languages, from JavaScript to Model 204, which apparently nobody else has ever heard of anyway. She's currently a senior web developer at Cash App, an active community in the Melbourne dev community, and has spoken at conferences around the world. If you see her at a conference, she'll probably have knitting needles in hand. So I'm sure we can find out a bit more about that. But everyone, please give a warm welcome to Erin and refactoring components.
Hi, yeah, so I originally called this talk refactoring components, and then one of my coworkers pointed out that that was pretty boring, and I was missing out on an opportunity to go getting on the refactor tractor. So that's what we're going with. As was just mentioned, my name's Erin. I work for the company formerly known as Square, which is now known as Block, and I specifically work building a product called Cash App, which you may not have heard of because it's not currently available in Australia. But our aim is basically to fix the truly atrocious situation that is the banking sector in the US. You think we've got it bad here? No way. But we do have offices here in Australia, and we are very remote friendly. So if you're looking for a change, maybe come have a chat. Like I said, I will have my knitting needles around. I'll be knitting socks because this year I decided for some reason I was going to knit everyone's socks for Christmas. So now I'm going to knit like 10 pairs of socks by the end of the year, and there's no, like once no going back from that yet, right? I'm stuck. And if you would like to follow along at home, the slides are available at refactortractor.ez.codes, and they really are there this time, not like at the last talk I gave. All right, so today we're going to talk about refactoring. We're going to start with what refactoring is and when we might want to do it. We're going to look at some occupational health and safety, so some tools that we can use to ensure that our refactoring happens safely. We're going to look at some additional tools we've got available for working with JSX, and we're going to do lots of live examples because I like living dangerously. All right, so what is refactoring? Refactoring is when we change the implementation without changing the functionality, right? So we're changing the code, but we're not changing what it does. There's a few reasons we might do that. We might want to make the code easier to understand. We might want to make it easier to test. Or mostly we want to make it easier to change. So some things that we might do while we're refactoring are things like renaming variables, right? Maybe the variable names have got out of sync with what's actually going on, and the code is hard to understand. Rename the variables, make it a bit easier to understand. We might take long functions and split them up into smaller functions, which also makes the code easier to understand because it's easier to reason about the smaller pieces, as well as making it easier to test, because we can test the parts independently. And we might do things like, we've got some repeated code, we might factor it out so it's just in one place, which makes it easier to change, right? We only have to change it in one place later. If you're interested in this kind of nitty-gritty details of refactoring, I highly recommend that you check out Martin Fowler's book, Refactoring. He's got like a whole taxonomy there of like the different moves that you can make in refactoring and like how to do them and all like when you might want to do those different things. But we're not going to get into quite that nitty-gritty detail today. Okay, so now we know what refactoring is. When should we do it? And my sort of cop-out answer is when the benefits outweigh the costs. And I say that's a cop-out answer because that's when you do anything, right? When the benefits outweigh the costs. So what are the benefits and the costs of refactoring? The benefits of refactoring are, most importantly, the biggest benefit you're going to get from it is faster future development, right? If you spend some time refactoring your code so that it's easier to build things, change things, fix bugs later on, that's a huge benefit of refactoring. Refactoring also often leads to less bugs. If we're making code that's easier to test, then it's easier to find the bugs that we do put in there. But also if we're making our code easier to understand, we're less likely to put the bugs in there in the first place. And finally, refactoring is a lot of fun. I don't know about you, but I get a real thrill out of taking some code that's a huge big mess and cleaning it all up. Maybe that's just me, I don't know. There are some costs though. The biggest cost of refactoring is time. If we spent a day refactoring our code, then that's a day that we're not spending building new features or fixing existing bugs, right? So we need to take that into account. We need to make sure that that trade-off exists. And there's also some risks with refactoring. So I found this delightful haiku on Twitter by another person named Erin, I was pretty happy to see. And she says, "This code used to work. Hey, I should refactor it. Now it does not work," which I found very relatable. Now, she was a woman on Twitter, so obviously what she got was a bunch of men telling her that she should just have written better tests. Which is easy to say, but it can be quite difficult, right? It's hard to write tests for code when you don't know what it was intending to do in the first place, right? It's quite tricky to write those tests. And also when you are writing those tests, often you'll pick up existing bugs in the code. And sort of, you can't just go around fixing them. Because often, like if you've got bugs in your code, your users might have workarounds that they've built to deal with those bugs. And when you fix the bugs, you're going to break those workarounds. The best sort of example I can think of with really regards to that is Internet Explorer, which was basically one big bug. But the way that it was written, if Microsoft had gone in and fixed all of the bugs in Internet Explorer, it would have broken millions of websites around the world, right? So IE had its issues, but their hands were tied to some degree about the buggy behavior. Okay, so as an example of some code that I did not refactor, this piece of code comes from a code base that I was working on last year. It was in this component. It was like a huge component, like 1,000 lines long. That's my favorite. And I was working in a different part of that component than this particular function. Now, I hate this function. This upsets me immensely. This should be like 3 lines of code. There is no need for any of this. But it also wasn't worth refactoring it. Like, I wasn't doing anything with that bit of code, but also this code works. It's easy to understand. It's easy to test. Apart from the way that it annoys me, there's not really anything wrong with it. So I didn't touch it. Resisted the urge. As far as I know, it's still in the code base, but I don't have to look at it anymore. Okay, so as a general rule, I only refactor code if I'm doing some other change at the same time, or someone else in my team is doing some other change. So that has the advantage that, first of all, I know that the refactor is going to be worthwhile, because it is going to speed up the feature work that I'm doing. But also it means that there's a bunch of people with their eyes on this code at the moment, right? The other people in my team, our product managers, our designers, everyone's looking at what's going on in this part of the code base. Our users are expecting a change anyway. There's a better chance that if I do accidentally break something or accidentally fix something, that somebody's going to notice and we can deal with it appropriately. Okay, so we've sat down, we've made our decision, and we've decided we're going to refactor some code. The specific refactor we're going to do is our code base is using Moment.js for handling date times. Moment.js was an absolutely fantastic library for managing dates and times in JavaScript when it was invented, I think 10 years ago. But these days, it's a little bit heavyweight. It uses mutable dates, which sort of result in bugs. And the managers of Moment also suggest that perhaps Moment is not the library to be using for you. So we've decided that we're going to switch to date functions, date FNS. The specific bit of code that we're going to refactor is this function here. So it's a function which formats a date, takes a date. If the date is falsy, it returns an empty string. Otherwise, it uses Moment to convert the date into a string in the format yyyy-mm-d. All right, so how are we going to approach this? I like to take sort of 3 steps when I'm refactoring code. So the first is we're going to use tests to determine what the current behavior is. Then we're going to refactor the code, and then we're going to write our feature. And we're not going to do step 3 today, because I'm assuming that you are all already really great at writing new features, and we're just going to concentrate on the first 2 steps. So the way that we're going to determine the current behavior is using something called characterization tests. So characterization tests come from a book called Working Effectively with Legacy Code by Michael Feathers. If you do work with legacy code and you would like to do it effectively, this could be the book for you. But today we're just going to talk about characterization tests. So characterization tests work a little bit differently to the tests that you would normally write when you're building a feature. So when you're normally building a feature, what you would do is you would write a test with some expectations. and then you write the code to make the test pass. Assuming you're doing TDD. I don't know, if you don't do TDD, I guess you write the code, then you write the test, then you realize the code's wrong, you go back, change the code, wonder why you didn't just write the test first. I don't know. The characterization test, though, is the other sort of way around, I guess. We write a test with no expectations. And then we change the test until we change the expectations until the test passes. So with feature test, the code changes, but the test stays the same. With characterization test, the test changes, but the code stays the same. The most important thing is that we're only ever changing one or the other, right? You're either changing the code or you're changing the test, never both at once. So what does that look like? Oh, wrong way. Here we have, can everybody see that? Because, yeah, cool, because I can't make it any bigger than that, I don't think. So that's lucky. So we have our function here, and we're ready to write some tests for it. So we're going to describe our format date function. Now, when I'm writing tests, I like to start with the very simplest case. So when we pass in nothing, what's going to happen then? And this is a characterization test, right? So we don't know what it's going to do. I guess it's going to return something. It returns, we don't know. And then we can write the actual test. Is going to be expect format date, passed in nothing, to be, and again, we don't know. So what happens when we run the test? We can see that it fails because, I guess unsurprisingly, our date function doesn't return 2 question marks. And we can see that what it does return is an empty string. So now we can update our test and say it returns an empty string, and write the test, and now the test passes. Okay, so then we can do that for our other scenarios. So the next one is going to be when we pass in date. So the things that we can pass into this function are sort of determined by what you can pass into the date constructor. So it's going to be a date, a string, or a number. So we can pass in a date. Again, we don't know what it's going to return. We'll pass in a new date. When I'm doing this kind of thing, I like to use dates that are like have all the numbers below 10 so that we can see where the padding is going to end up. And we can see that it fails because it returns this formatted string. So we can say it returns a formatted date, I guess. Cool, so that's our date scenario. And then we have the strings. So when we pass in so with strings, there's kind of 3 scenarios that we can have here. The first is that we can have a valid date string, which is just going to look like our date. And I'm just going to go out on a wild limb here and say that this returns the same thing as the previous one, which it does. We can also pass in a string that looks like a date, but isn't. So an invalid, pass in an invalid date string. So that's going to be something like the 31st of February. Right, so we don't know what that's going to return. Oops. And it turns out that it actually formats the date for us and turns it into a valid date. So again, it returns a formatted date. Apparently the 31st of February is just the 3rd of March. Makes sense, I guess. The other thing that we can pass in is a string that just isn't a date at all. So it returns, we don't know. And a thing that isn't a date would be like, say, a banana. That's a completely different kind of fruit. And what's that going to return? It is going to return the string invalid date. So we can stick that in. And we're going to expect it to be invalid date. Excellent. So that just leaves one more scenario, which is the case where we pass in a number. So again, there's sort of 3 number scenarios to consider. So when we pass in a number, so when we pass a number to the date constructor, what we're passing in is the number of milliseconds that have passed since midnight on the 1st of January 1970, because of course it is. So we can get that value just by calling getTime on a valid date. Oh no, it didn't work. Because you have to put, Oh, it has to be a new date. You have to put all of the things in, right? You have to actually make it a date. You can't just call getTime on a string. It doesn't work. All right, have all the brackets lined up? Yes. Okay, so then the other two cases, well, the first of the other two cases for a number is if we pass in a negative number. So in this case, a negative number is going to be one that was before the 1st of January 1970. I don't know if anybody can imagine a date that long ago, but so that's just going to format. That's the way that you would expect. This kind of testing really gets you to exercise those copy and paste skills. It's exactly what we've been training for. Cool. And then the last case that I always used to like to test with numbers is the number 0. So when we pass in 0, it's going to return, I don't know, it could be anything. Let's just pass in 0 here. Is the suspense really getting to everyone? Yes. Okay, so this has failed, and what it's actually returned is an empty string. All right, so this is a bug in our code. And the reason that this bug is there is because we've got this test right at the start that says if the date is falsy, return empty string. And 0 is, of course, a falsy value. Now, we could go ahead and fix this, but like I said, we try not to do that when we're refactoring. So instead, we're just going to document the fact that it has this odd behavior in our test here. Now, the reason that I wouldn't fix this, even though it would be low risk, it's unlikely to break anything if I fix it, but there could be people in our code base who are using this function and who have written some workaround code, and their workaround code isn't going to make any sense once we fix the bug. So it would sort of just be, saving a bit of tech debt if before we fix this bug, we go and check who else is using it. So we'll write up a Jira card, stick it on the board, someone else's problem for later. All right, so that's all of the tests that I would write for this. We could keep going, right? It's JavaScript, so we could write a test for what happens if you pass in a Boolean. And the result of that would actually be kind of interesting, because if we passed in false, we'd get empty string, but if we passed in true, we'd get invalid date. But I'm not going to do that for two reasons. First of all, if this was production code, I'd just use TypeScript. The only reason I'm not using TypeScript here is because it's real long and it takes up too much space. But yeah, just use TypeScript. And the other reason is that if you're in your code base, you've got to the point where people are passing Booleans into date formatting functions, you've got bigger problems. Maybe deal with those. Okay, so now finally we're ready to do our refactor. So like I said, we're going to use the date FNS. I feel like it's pronounced date functions, so date fins. Format from date fins. We're going to replace moment with that. So date functions, the format function is going to take a date, just like moment did, and it's going to take a formatting string as a second argument, but it's a slightly different library, so obviously it needs to use a slightly different formatting string, because it wouldn't be JavaScript if we didn't. And we can see that all of our tests have passed except for one, and the one that's failed is the invalid string. You can see that there. It is actually throwing an error rather than returning a string. I would argue that this is actually better behavior, but like I said, we're not trying to change anything here, we're just trying to keep it all the same, so we can just wrap this in a try catch. And instead return invalid date. Is it capital letter? We'll find out. No. Okay, so that's our refactor done. Now you might ask, was this really worth the effort? Right? This is like 8 tests or something for 4 lines of code. And the answer to that is, just like with everything else in software development, it depends. If this function was used by like one component and we always knew what was going to go into it, no, of course I wouldn't write all these tests. Just maybe write one. Maybe cover it by the component tests. But if this was like the formatting function that's used across our entire code base, so I made a change like this in a real live code base recently, and the function in question was used in over 300 places. So to me, 7, 8 tests for 300 usages, that seems like pretty fair. So yeah, you're always going to have to make that call for yourself and work out just how many tests you need. Okay, so that's how characterization tests work. But the next question here is, how do we do this with JSX, right? JSX works a bit differently. How is that going to work? So imagine we have this component here. It's a user info component. It's going to take in some user details, and it's going to print out the user name was born on, and then the date formatted using our format date function we just refactored, and also the day of the week, right? So Bob was born on the 1st of January 1990, which was a Monday. Okay, so how does that work? So we have our function here. We can describe user info component. And we just say it does something. We don't know what. So we can render the component. Oh, you got to put all the brackets in. And the user is going to have a name and a birthday, which we can say is the 1st of January 1990. Okay, so how can we test this? Well, the first thing that we can do is we can grab a reference to the container. So when we render a component with a test library, it gets rendered inside a div, and this container just points to that div. And then we can expect the text content of that container to be something. So we can expect container to have text content. And we don't know what it's going to be, so we can run our test. And just like with our standard JavaScript, the test will fail, but it tells us what to expect. So we can pop that in there. Whoop. And we can say that it renders the user details. Okay, so that works great. So it works well in cases where you can just expect the text content to be a specific thing. If you've got large, complicated components, it can get a bit messy, or if you're expecting different kinds of behavior, this perhaps isn't going to be an easy way to do things. So the good news is we do have another tool available to us, and that tool is snapshot tests. So snapshot tests, if you're not familiar with them, and I'm guessing you are, because you seemed very happy about them. If you're not familiar with snapshot tests, the way that they work is that when you first run your test, it generates a snapshot. And a snapshot is just a text representation of your component. And then you go ahead and you make your changes, do whatever you need to do. And then when you run the test again, it's going to generate another snapshot, and it's going to compare the original one with the new one, and it's going to tell you if they match or if they're different. So let's try that. So here we can grab this same test again. And the test that we're doing now is we're just going to say that it matches the snapshot. Matches the snapshot. And then instead of testing whether it has text content, we can just say we can expect it to match snapshot. Cool. And now when we run this, you see the test passes. You can see down the bottom here, one snapshot written. And we can see we've got this new folder here called underscore underscore snapshots underscore underscore. And a file that has the same name as our test file with .snap on the end. And in here you can see this is the text representation of our component that's been generated. If we jump back into our test and change something, so we say, actually it turns out Bob was born on the 2nd of January, we rerun the test. This time it fails. It says that the snapshot failed, and it shows us what the difference is, right? It was rendering the 1st, now it's rendering the 2nd. It was rendering Monday, now it's rendering Tuesday. Now we know that that's actually correct because we just changed the value, so we can just hit U and update the snapshot. And now if we look at our snapshot, you can see it says Tuesday, everything's happy, our test is great, we know we haven't broken anything. All right, cool. So snapshot tests are very handy for this kind of thing, but they do have some limitations. So the first is that you lose a lot of clarity when you're using a snapshot test. So imagine that we have this component called increment that we're testing. We've got a snapshot test on the left. And all we do is we render the component, and then we expect it to match the snapshot. Then we click a button, and we expect it to match the snapshot. But there's not really information there about what's going on. Whereas if we wrote a more traditional kind of test, what we get is we render the component, and then we expect it to have the number 4, which just so happens to be that same as that initial number that we passed in. So that's probably a good hint that it's rendering out the number we passed in. Then we click the button, and we expect it to have 5, which is a good hint that probably this component called incremented the number that we passed in. So there's just a lot more sort of detail for the next person who's looking at this component in a more traditional test, which can have pros and cons. Also, snapshot tests don't render all of the information about the component that you might expect them to. So imagine this component. This is called clickymajig. Clickymajig renders a text box onto the screen. When you click the checkbox, it waits 2 seconds, and then it unchecks the checkbox. I can't imagine any situation where this would be useful. But I wrote a test for it anyway. So this test is using snapshots. It's going to use fake timers, because we need to handle that 2-second delay. It's going to render our component. We're going to check the checkbox. We're going to check that it matches the snapshot. Then we're going to wait 2 seconds, and then we're going to check that it matches the snapshot again. And this test will pass. This test will pass even if we take out the wait for 2 seconds. This test will pass even if we break the component so that it doesn't do anything other than render a checkbox. And the reason for that is that the snapshot that gets rendered looks like this. Right? It just says that there's an input with a checkbox. We've got no information about the state of the checkbox in there. So it's just something to be careful of. I've run into similar issues with snapshot tests where people had written the snapshot, but the component loaded everything asynchronously. So there were all these tests, but all they were was like this empty component, and they weren't really testing anything. So just make sure that your snapshots do contain the information that you need them to. And the third limitation of snapshot tests is that you can't do TDD with them. You might say, I don't care, I hate TDD. And that's fair enough. Or why do we care about TDD? We're refactoring at the moment. And yes, that's true. But we're refactoring, remember, because we're intending to make a change. And when we go to make that change, the snapshot tests aren't going to provide us a good basis for those new feature tests that we're going to write, because they do lack that clarity. That's not to say that they don't have a place, but it's probably worth considering whether you need other kinds of tests as well. OK, snapshot tests are really excellent in 2 situations, though. The first is when you have those big 1,000-line components and you don't want to test every single thing that's going on in there. Snapshot tests are excellent for that. And the other place I quite like them is things that have got a lot of presentation logic. I don't know if you've ever tried to write tests for a table, but they're a mess, they're brittle, and they don't really have that good information in them, right? So this is a good use to just use a snapshot test instead. It's simpler. OK, so that brings us to the example part of the whole thing. So we're going to look at an app called the Old Farm Shop. The Older Farm Shop. The important thing to remember here is that letter at the start isn't a Y, it's a thorn, and it's pronounced th. So in English, we used to have this letter thorn. Then the Dutch or whoever it was came along with their printing press, and they were like, we don't have that letter. You don't get to have it anymore. Get rid of it. And it sort of looks like a letter Y, so people started using the letter Y, and then we ended up with this situation. But it is legitimately pronounced th. The Older Farm Shop. It's important. OK, what does that look like? This is our app. We're selling farm produce. So you can buy plants, you can buy seed packets or seedlings, and you can pick different numbers. Don't buy 0, that would be weird. And you're going to get sort of the unit price in this little label here, a subtotal, a postage cost, and a total. We're all good with that? It's not too complicated? Cool. We've got some new requirements. So we want to add a third product type. So we want to add a new radio button that says plants. We're going to show the unit price and the total price for a plant, and we're going to calculate the postage for a plant. So it'll start looking like this. Now, we could, in theory, implement these requirements in the order that they were given, but we're not going to do that. And the reason for that is that if we implement that radio button first, then we've got to do the whole thing in one go, right? We can't stop halfway. Whereas if we start with the label, we can just implement the change we need for the label. We could merge that in. It can go to production without the rest of it, and it'll all be fine. So it's sort of like a cheating feature flag, I guess. You could argue that this is a very small change, and you could just do it all in one go, and you're absolutely right, but we've got time limits on this talk, and I'm not confident that I'm going to get through the whole thing, so we're just going to start with the label. All right. Now, here is the component that renders this page. It's not an amazing bit of work, but it's what we're working with. So the bit that we care about is this label here, except actually it's these two labels here because we've just repeated all this code for both. This is actually some production code that's had its identity changed to protect the innocent, but this was real code in production. So we don't want to write another block like this, right? Because we don't want to have more repetitive code in there, but also because we can't write a test for changing the label with the code all glommed into one component like this, right? We need to separate it out. So we're going to start by creating a new label component that is separate to everything else. Before we do that, though, we're going to write some component tests, some characterization tests. So this is going to be the product.test.jsx. Do not accidentally write TSX because VS Code will be like, oh, it's a TypeScript project. I'm like, actually, it's not. And it'll lead to sadness. Okay, so we're going to test our product component. Now we've got 4 scenarios that we need to test, not 7 or 8 like the last one. This is 4. So that's going to be when we've got seed packets selected and we've got no amount entered, when we've got seed packets and an amount, when we've got seedlings and no amount, and seedlings and an amount. It's going to be a lot of copying and pasting, I promise. So when seed packets is selected and no amount is entered, now this, we've got a great big component, we only care about a small part of it. This is an excellent use for snapshot tests. So it matches the snapshot. All right, so we need to grab a reference to our container. Screen.get. No, not screen. We want to render the component first. Product, that product, which takes a prop called product. We're going to do because why not? We need to import that. No, import it. Yeah. All right. I'll type it myself. Okay. No, not that one. Okay, we got there. No thanks to you, VS Code. We want to grab a reference to that radio button. So that's going to be seed packets equals screen.get by role. The role of a radio button is radio, nice and easy. But there's a couple of radio buttons on the screen, so let's pass it in a name as well. And then we want to click that radio button. All right, we need to import screen as well. And that's it. Then we can expect our container to match the snapshot. And we do that, we get a snapshot generated, and everything is great. Okay, so then we've got our second scenario, which looks a lot like the first one, except an amount is entered. So we're going to grab a reference to the, well, I think it's called number or count or something, I can't remember. I'm going to do screen.get by role. Now this time it's an input of type number. So as everybody knows, the ARIA role for that is, yes, spin button. There's only one on the screen, so we won't worry about a name. We're going to pass in 4, say. All right, now the snapshot written, excellent. Then we just need to do the same thing all over again, but with the seedlings. So when seedlings is selected and no amount, then grab seedlings. I guess we should rename this too. And when seedlings is selected and an amount, this is going to be seedlings, seed kings, and seedlings. All right, we're going to render the rest of our snapshots. Oh, something failed. What failed? The name? This one? Ah, well spotted, especially when it wasn't on the screen. All right, so we got all of our snapshots written. Everything looks great, except actually we have this warning that's being thrown. And if you've spent much time writing test React, you've probably seen this warning before. This warning is a lie. It has nothing to do with anything being wrapped in act, and it's very misleading but important. So what causes this warning is when the component state is updated after the test has finished. So in our case, we change the number of things, which changes, which calls this state, which calls this use effect, which calls this calculate postage function. And when it's seedlings and it's not 0, it gets down to this postage calculation, which calls this asynchronous function. So we call this asynchronous function, it goes off and does its asynchronous thing. Then our test finishes. Then the asynchronous function returns. Then the state is updated. And then React is like, oh my god, I'm going to tell you lies about act. So that's what's causing the warning. Like, it's a legitimate warning. It's just that it's not very helpfully worded. So the way that we can deal with that is we can just kind of wait for it not to be 0. So we look at the snapshot, for instance, we can see postage, total, no, the next one. We can see that the seed packets, oh my god. When seedlings is selected and an amount, that's the one. Okay, we can see the number is 8, but the postage is 0. So we can say the postage equals screen.getByText. Let's just do a quick regex because nothing ever goes wrong when you do that. And then we can await for, and then expect postage to have text content, and whatever it's going to be, we can just run the test and see. Oh, you have to make it an async function all the time. Okay, so we can see the postage is actually $32. So we can change that. And this is a slightly hacky way of doing this, but you get the idea. So now our snapshot's failed because instead of $0, it's $32. Instead of 32, the total is now 64. That's what we were expecting, so let's update the snapshot. Okay, so now we've got our characterization tests. We can do our refactor. Now I'm just going to write the new component sort of inside here because it's going to make it easier to copy and paste. But in the real world, you'd probably put it in its own file, and it could have its own independent life and be happy. So we're just going to return the same value we have here. Now in this case, you can see we've got 2 bits of text that are essentially the same thing. So rather than having it all repeated, let's kind of parameterize it. So we can pull out those names, and we can say seed packets is going to be seed packets, and seedlings is going to be seedlings. And we can get rid of all of that, and we can just say number of names product type. Oh, don't put a $sign there. You're out of control. And again here, instead of this being seed packets, it can just be product type. Then we need to pass in product type. And we need to pass in count, because we're using that here. And then we just change this one more, product type. And then we get rid of all of that. We put one more closing bracket. We wish we'd set up prettier so that it reformatted everything. And it doesn't do anything because you haven't used it yet. Okay, so now we can replace all of this with our new label component, which takes a product type and a count. And we run our snapshot tests again. They all fail, but the only reason they fail is that the white space has changed because we've added in all of those interpolations. So we can just update that, and it's fine. Cool, so this is looking pretty good, except there is one more little dependency in here that's not super obvious, but this ID on this input needs to match the HTML4 on this label. And we need those two things to be the same. There's a couple of ways we could deal with that. We could just hope that no one changes it. We could pass the ID into the label, which could work. But what I would suggest that we do is we kind of accept that these two, this label and this input, are very tightly coupled. And probably the best thing to do is just to put them all into the component together. So now instead of this being a label component, it's going to be a number input component. We're going to wrap it in a div. Get rid of that bracket. And paste all of that in. And the closing div. Oh, don't you wish I'd installed Prettier? Okay, so this is now just missing this handle count change. Handle count change is kind of a weird name for a prop, so let's just call it on change. All right, so now that's all good. We can go back up here. We can change this to our number input. We can pass it the on change. And then we can get rid of all of this. This is my more favorite thing than refactoring is deleting code. So that brings me great joy. And our snapshot test will pass, so that's all good. Everything is great. And now we're actually ready to write our feature. Except one small thing. Before I did that, like I said, I don't like having snapshot tests as the basis for my feature tests. We could go with that, but what we have here is sort of snapshot tests that cover the whole product component. We don't have any tests that are specific to our new number input component. So I would start by actually replicating our snapshot tests into like a specific set of tests for the number input. I'm not going to make you watch me do that though. I have a set of tests here already. You can see they're the same scenarios that we wrote before for the two different types and the amount and no amount. And then one additional test which checks that we call the on-change handler, because now that these two things are separated out, we just need to test that integration is working. Now you might argue that this is a waste of time. We already had these tests. I don't need to do all this. And look, I don't know how busy you are, but I did time myself when I wrote these tests initially, and it took 4 minutes. So it's that you just got to get those copy and paste fingers going fast. Okay, so now we've got these tests here. We're ready to write the test for our new feature, which honestly is going to look just like the existing ones, except we're going to replace everything with plants. So when the product type is plants, it's going to be plants. It's going to show the number of plants. And plants, as I'm sure you all remember from the spec, cost $15 each. And again, we're going to make plants. We're going to have 12 of them. We're going to make plants. And 15 times 12 is, of course, anyone? No? 180. Yeah. We run those tests. They fail because we haven't written that code. But now, when we actually go to write our feature, it's going to be so easy. Like, all we need to do is add plants to our little names here. And then there's a little config file here that has the prices in it. And we can add the plants here. And our test will pass. So how fast was that after we did that refactoring? So this component is now super easy to change, super easy to work with. Okay, so what did we learn today? Some important things. We learned to think about when we should refactor, because even though it's fun, sometimes we maybe shouldn't do it. We've learned how to write characterization tests to ensure our refactors are safe. We've learned about snapshot tests and how we can use those to write refactoring tests. And most importantly of all, we learned that this thing that looks like E is actually pronounced the. And that's what a thorn sort of looks like normally. All right, I've been Erin Zimmer. If you would like to see the slides are available here. Don't know why Firefox hates rendering the P's in this font, but for some reason. The examples are up on GitHub with a completed example as well. And thank you all very much.